Tired of manually checking stock prices? Let's build a Python scraper that gets data from Nasdaq using residential proxies. By the end, you'll have clean CSV file for multiple stocks ready for analysis. The prerequisites for this are Python, Playwright, and residential proxies for avoiding IP blocks. In this tutorial, we'll use Decodo residential proxies. First, I'll show you how to scrape individual stock pages, and then we'll see how it works for historical data of multiple stocks. Let's start with individual pages. Open a text file and start by importing the packages. The Sync Playwright library allows the usage of Playwright for browser automation. Datetime captures timestamps for each price update. Meanwhile, CSV saves our data to a file. Next, we set the target URL. Since we're monitoring NVIDIA stock on Nasdaq, this is the page we'll scrape for real-time price updates. Now, let's set up proxy configuration. We need three things: username, password, and the proxy server address. Don't forget to replace this with your actual Decodo proxy credentials. Then, we start Playwright with a context manager. This launches a Chromium browser. Headless set to false means the browser window will be visible. Here's where we set the proxy. We pass in our proxy server, username, and password. This routes all browser traffic through Decodo's residential proxies, keeping you safe from IP blocks. After this, we create a new browser context and open a page. Think of context as an isolated browsing session with its own cookies and cache. Next, initialize a state dictionary to track prices. Last price stores the most recent price, while price history collects all price updates as a list. Define a function to handle network responses. This intercepts API calls from the page. First, we check if the response URL contains the stock info endpoint. If it does, we parse the JSON and extract the ask price. If there's no ask price, we skip this response. The following code captures the current timestamp and formats it as year, month, day, hour, minute, and second. Now, we determine the price status. If this is the first price we're capturing, we mark it as init, otherwise we grab the previous price to compare. Next, let's compare the current price to the previous one. If it's higher, the status is rise. If lower, it's drop. If the same, unchanged. Each status gets printed to the console with the current price. Then, store the data in our price history. Each entry contains the timestamp, price, and status. We update last price with the current value for the next comparison. The except block handles any parsing errors without crashing the script. Now, attach our response handler to the page. Every network response triggers our function. Then, we navigate to the Nasdaq URL and wait for 60 seconds. During this time, the page continuously updates and we capture all price changes. If we collect any data, it's saved to a CSV file. The code creates a dict writer with our three columns: timestamp, price, and status. Finally, we print confirmation showing how many records were saved. Last, close the browser. This cleans up resources and ends the session. Save the script as a Python file and run it in a terminal. In a moment, you'll see prices printed in the terminal whenever they update, and a new CSV file with a timestamp, price, and status. That's all for scraping individual stock pages. Now, let's move on to historical data. In a moment, I'll show you how to get multiple stock pages and save the info in dedicated CSV files. Open a new text document and import the needed libraries: Playwright for automating the browser, OS for handling file and directory operations, and Shootil for moving the downloaded files to our target folder. Now, let's sort out the proxy configuration. Replace this with Decodo credentials. The proxy server uses hostname and port format. Next, define which stocks to download and the time period. Tickers is a list of stock symbols. Timeline sets the historical range: 1 month, 6 months, year to date, or up to 10 years. Specify the base URL template with placeholders for ticker and timeline. Now, we set the output directory name. OS mkdirs creates the folder if it doesn't exist. The exist OK set as true prevents errors if the folder is already there. The following code launches Playwright and starts a Chromium browser. Headless parameter set as false makes the browser visible. Configure the proxy with our server address, username, and password. Then, create a browser context with download permissions enabled and open a new page. The accept downloads parameter set to true allows the browser to save files. Now, loop through each stock ticker,
For each one, we build the URL by inserting the ticker symbol and timeline. Then, we print the status and navigate to that URL. This section handles the cookie consent banner if it appears. The script waits up to 5 seconds for the accept button. If found, we click it. If not, we skip and continue. We wait up to 15 seconds for the download button to appear, then grab a reference to it. If the button exists, we scroll it into view. This ensures it's visible before clicking. Now, set up download tracking and click the button. Playwright captures the download and stores it in download info. We extract the actual download object into the download variable. We get the temporary file path where Playwright saved the download. If we have a file path, create a new file name using the ticker symbol, then build the full destination path and move the file there using shuttle-move. If there's no file path or no download button, we print an error message. Finally, close the browser and clean up resources. Again, save the script as a Python file and run it in your terminal. Once the script finishes, you'll see a Nasdaq data folder with 3 CSV files. In each file, you'll find historical data of your chosen stock page.
That's how you scrape stock data from Nasdaq. Ready to try it yourself? Get Decodo residential proxies with a free trial. The link is in the video description, along with the full code from this tutorial. For more web scraping tips and code snippets, check out our blog. And I'll see you in another video.